Okay, so now I'm going to do a little more with the uses of factoring. Okay, there was that. Um, there's a handout that you have in class. If you were in my Wednesday class, my Tuesday class is going to get it tomorrow. But there was two questions that we didn't have a chance to do, and I wanted to look at those. Number 11 and number 12. These are from. Oh, let me write that better. These are from the uses of factoring handout. And it had two interesting problems. Okay, one of them says this. It says a student is solving the equation x squared equals 13x. The student decided to divide both sides of the equation by x, so comes in and does this, and finds the solution to be x equals 13. The student checks the answer in the back of the book and finds that x equals 0 is also solution. The student feels that this is a misprint. What did the student do wrong? The answer was supposed to be x equals 0 or x equals 13. It's supposed to have that. And what did he do wrong? Was what you're supposed to answer. So that's number 11. So what it was in the very beginning where they have the x squared equaling the 13x, you need to subtract the 13x to get it equal to 0. And then rather than dividing by x like they did, you need to factor the x out. And then what's left is x minus 13. And then you set the factors equal to 0. And you get the two solutions being either x equals 0 or x equals 13. So you get the 13 like they did the first time. It's just you don't lose this solution. Okay, it's both of these. All right, so that's a really common mistake. And so you see up here when they divided by x, they just got x equal 13, but see how it's degree 2? You can catch that mistake. So you should have two solutions. And so just make sure you stick to that process of get it equal to 0 first, then factor. And sometimes it'll factor where you have just like x there, not x minus or x plus something. And so you wind up getting one of the solutions being 0. So that was number 11. And then number 12 said this. A student is trying to solve the equation x plus 9 times x minus 6 equals 6. The student sets x plus 9 equal to 6 and then set x minus 6 equal to 6. He found the solutions to be x equals negative 3. So we can see he would have gotten that by subtracting the 9 and then added the 6. Got the other solution to be x equals 12. When he checks by plugging in, they don't work. Like if you plug in a negative 3 into the original equation, you don't get 6. You get 6 times negative 9, which would be negative 54. It doesn't check. See that? So it doesn't check. So what's wrong? Like, where did this go wrong? Okay. So the issue with that is that they had it equal to 6. And what's going on here is that it's almost like somebody factored before they should have. That number on that right-hand side should be equal to 0. So what they should have done is they should have taken this problem and FOILed it back out. Okay. Go ahead and combine your like terms, get it completely FOILed, and then start over again. So what should have happened is, well, we should have subtracted 6 first. That would have, oops, darn it. That would have given us x squared plus 3x minus 60 equals 0, and then go from there. Now, we weren't really trying to finish this, so they didn't even try to really make it work, so I'm not going to finish it. But that's the mistake, is that it was equal to 6. This right here needs to be 0. Those are two common mistakes that people make, okay? So that's what the 11 and 12 on that uses of factoring worksheet were all about. All right. Also in this video, I wanted to go to the factoring review that you're working on. If you're in my Wednesday class, and those of you in my Tuesday class are going to get this handout next time. And I just wanted to look at a couple of the problems on that sheet. Okay, so here was one. This is number 21. Okay, it said 5r squared minus 39r minus 8 equals 0. And the directions on that were to solve. So it's already equal to 0. So you got to start your factoring. Okay, so we're going to do 5r and r. All right, so what I'm going to do is put an 8 and a 1 in there. Let me not put it in the right way. I would put an 8 and a 1 in, or a 2 and a 4, but because this is so big, I thought about using an 8. And I really thought about putting the 8 at the end right off the bat, but I wanted to like not have it be right the first time. See how this would be 8r and 5r? There's no way to get 39 out of that. But I noticed if I put an 8 here at the end, that would get me to 40. And if I put a 1 there, that would give me a 1. So there's a way to get a negative 39 if I make the 40 negative. So 40 negative, 1 positive. Okay, and of course that's the time-consuming part right there. Once you get that, then you're back to just solving a linear equation. So that means you set each of these equal to 0. And then you just go through that process of getting the variable by itself. So r equals 8, or you subtract 1, and then divide by 5, and get the r equals negative 1/5. And so there's one answer, there's the other answer. Okay? All right, let me see. Let me do one more from that top part. All right, well, let's look at 22. We'll probably do some of these during the study session as well. All right, so if we have a 49k squared minus 64, we could factor that. There's nothing common. I see perfect squares. It's a difference of squares. So I'm going to do a 7k and a 7k, an 8 and an 8, 1 minus, 1 plus. So then I'm going to set them equal to 0. I'm going to solve, and I'm going to get 7k equals 8, or 7k equals negative 8, and then divide by 7 on both to get my two answers. One of them's positive 8/7, one of them's negative 8/7. Okay. All right, now both of those started out equal to 0, but don't forget the example I showed on the previous video and also the issue that I showed you just right above. You got to get it equal to 0 before you factor. Okay. All right, and then let's do 2 from the bottom section. So number 24, this one said to simplify. So 24 just is a fraction that needs to be like written in lowest terms is what it says. That just means simplify. And then 25, it says multiply or divide and write the answer in lowest terms. And this one is a division. Got to make sure I copy all the signs correctly. All right, so we'll look at those two, and then that'll be all that I put in this video. All right, so if I'm doing 24, probably both of those have a cube in them, but when I look at the one on the bottom, I'm noticing how the cube, the z, I mean, there's 3 of them, then 2 of them, then 1 of them. All right, so I think the fraction on the bottom, I'll be able to pull out a z. All right, when I do, I get a z squared left, a 4z left in the middle, and a 16 at the end. Okay. And that's still squared, so I might try to break that down a little bit more. But when I do, my only options for 16 are 1 and 16, 2 and 8, or 4 and 4. And if I put in a 2 and an 8, I can't get a 4 in the middle. I only can get like a 6. So that's not going to work. If I put in the 116, it's even worse. Smallest I can get is 15. And if I put in the 4 and the 4, that would give me either an 8 or nothing. So it turns out that that really can't be broken down. After it gets to here, you can't break it down anymore. Okay, so let me get rid of that. I tried, but it just wouldn't work. Okay, now the one on top is a cube. There's no z on that 64. So that means I'm going to be thinking about the formula, which means I need to know what got cubed in each case. So let me think about that up here. So z got cubed to make z to the third, and then this would need to be a 4. Don't plug 64 into the formula. Then the formula says you're going to get 2 terms and then 3. And if it's a plus formula, this is what it would look like. So a cubed plus b cubed. So in place of the a, you put a z. In place of the b, you put a 4. So it's going to be z plus 4 z squared minus 4z plus 16. Okay. And then notice that it's kind of weird, but that this right here is exactly the same as that right there. And so that whole thing over that would always equal 1. So I'll be able to divide that out on the top and the bottom. And all I see left is a z plus 4 over a z. And remember that z plus 4 is in parentheses. So you can't break it up at all. You can't have just a plus sitting there. One of the teachers likes to say that these are folks are married. They're in the parentheses. So you can't break up married folk. You don't want to go in there and knock out the z. So this right here is your final answer. Okay. Now that was just a single fraction. Now over here on this one, I've got one very similar to what we did last time, and it's a division right here. So first step is going to do the keep. Let me write this a little bit lower so I can do my factoring the way I like. So keep the first fraction. I just like to leave a little space so I can factor above and below each of these. Then I'm going to keep, change, then flip. So I get to there. All right, now what I'm going to do is, once I get it to multiplication, I'm just going to start factoring. So I notice on these that these are all pretty good ones to factor. They all have just a 1 out in front. So I'm just going to get started. Nothing was common, so I started unfoiling. And everything comes from the 14 since this is a 1 here. So I know it's got to be 2 and 7. And then to make it positive 9 and a positive on the 14, I need them both positive. Now, once I get one thing factored, I'm going to start seeing some of that showing up. So now I'm going to go to some other location. I'm just going to go to this one. All right, again, nothing's coming from out in front, so everything making the middle term has to come from 16. So it's not 1 and 16. I think it'll be 2 and 8. I like the idea of the 2 because I already saw a 2 up there. Both of those would need to be positive. All right, now you go wherever you want. I'm seeing this right here. This is probably the hardest one to factor. People forget that sometimes all there is to bring out a common factor. See, there was a z common, and then there was a z plus 7 left. Okay. Now above it, nothing's common, so I'm going to unfoil. Nothing's coming from the beginning. I'm thinking about 16. I'm thinking about 1 and 16, 2 and 8, or 4 and 4. 2 and 8 would give me a way to make a 6 happen. But the only time that works is when there's a 1 out in front. So that your middle term has to come from how you break up the 16. And I'm trying to make a positive, so I'm going to make the 8 positive and the 2 negative. Okay. All right, now at that point, I've already got it to multiplication. I've already factored everything. So now what I'm going to do is look for common factors on the top and the bottom that can be canceled out. Because, you know, if we had something like this, if we had multiplication like this, then 6 divided by 6 would just be 1. That's the idea. So z plus 2 always has the same value as z plus 2. That would equal 1. We can cancel it out. Here's a z plus 8 on top and a z plus 8 on the bottom. Here's a z plus 7 on top and a z plus 7 on the bottom. And then that's all you can do, because don't be tempted to break up the married folk. The z minus 2 is a factor. The minus, you can't separate the z from the 2 and knock the z out. So on top, you have a z minus 2. On the bottom, you still have a z. That would be your final answer. Okay. All right, so I just wanted to do a little more on uses of factoring. Now just really work hard on completing the factoring review, the pages I passed out, and then doing the homework on factoring, getting those 2 things done. All right, so let me stop this and post it, and then I'll also post the factoring review.